Hello everyone, I am Dr. Manoj Srivastava from Department of Physics, DAV College, Gorakhpur. In the previous lecture, we have discussed about the salient feature of magnets, and we have seen that these materials are very useful for the application point of view as well as research point of view. In today's lecture, we will give a brief introduction how these materials are classified. These materials, as we can see in this pictorial diagram, that these are classified as large bandwidth magnets, intermediate bandwidth magnets, and small bandwidth magnets, which is known as also low bandwidth magnets. So, the material which comes into the large bandwidth magnets are LaSrMnO3. The examples for intermediate bandwidth magnets are NdSrMnO3 and SMSR MnO3 comes into the low bandwidth magnets. We can see that from this phase diagram there is a large gap or there is a large space up to which a single phase can exist. When we come to the intermediate bandwidth magnets, we can see that up a, in a very certain composition range the multiple phases start coexist, just like charge ordered insulating state, ferrometric insulating states, ferrometric metal states, which is inbuilt between antiferrometric A-type ordered states, antiferrometric insulating states, and when we move further towards the low bandwidth magnets like SMSRM3, we can see that the very critical phases exist. Up in a very certain range, we can see that multiple phases coexist. These magnets shows a very intense phase competition between the metallic and insulating phase as well as parametric, ferrometric, antiferrometric phases. That's why these materials are very tough, very scant studied because of these phase competition of these materials are also multi-critical and shows a very strong phase fluctuation amongst all these degree of freedom. These magnets are of our interest because they show a very sharp drop in resistivity up to a certain magnetic field, and they shows the transition temperature up to 130 to 140 Kelvin. At 130 Kelvin, we have seen that there is a most abrupt IMT in the composition range 0.45 to 0.52. These materials shows the ferrometric phases in between zero point 0.3 to zero point 0.52 and antiferrometric insulating phases above that of 0.52 range. These materials also shows zero point 0.4 to zero point 0.6 a charge ordered states which increases from 140 to 205 Kelvin with X. These materials have a very strong phase coexistence in between 0.45 to 0.52 and this colloidal magnetoresistance, as we have discussed, that which is the huge drop in the resistivity with the application magnetic field, shows a very sharp drop in resistivity in all the composition ranges from zero point 0.3 to 0.52. Near half doping, these magnets shows a phase separation due to the competing ferrometric metallic phases in and also antiferrometric charge order phases, which when creates metamatic states. The composition temperature range of these materials is intrinsically fragile with respect to external perturbation because when we apply a magnetic field or pressure, these materials shows the changes in the transition temperature as well as the insulator to metal transition and para to ferro transitions. Hence, these materials are very fragile with the external as well as internal perturbations. The internal perturbations can be applied by creating oxygen vacancies and also lattice strain. So that's all for the today's lecture. We will discuss more about these magnets in the next slides. Thank you very much.